The more or less, well, this training will be done by me and Kinda Alshamas. I will do a kind of introduction about the mixing principles and theory, let's say. Kinda, after me, she will show you how to select the mixers, and she has prepared a guideline for you afterwards. So you can even do the design later on, following this guide that Kinda created. And after such explanation of and training from Kinda, I will show you another two tools that will help you to price the mixers. We are using the local price list in Portugal, where you have specific discounts each of the partners. And in any case, if you have any doubts about discounts or whatever, of course you can contact your key account manager. So once I said this introduction, let's go directly to the presentation. Okay, I guess you can see my screen. So first of all, I put here some useful information and contact information for mixers. As you probably know, we have in Xylem a specific email address for all the requests for quotations. So anytime you need our support, not just for mixers, I would say for everything, you can send an email, a request for quotation to such email address. That is orcamentos.xylem.com. In case that you have problem with Solver, I guess that you know this tool. Solver is the design, let's say, and selection tool for pumps and mixers. Both are now under the same design tool, and also Lovara. So anytime you have any problem with access some of the configuration and modules inside the Solver, your contact will be Domingo Vigil. He's the manager, let's say, of this tool in Iberia, and the person who provide the access. The technical contact person should be the same as you have for the pumps. And of course, if you have any business related issues, you should contact your account manager. Also, Germán and David Garrido, they created a partner portal. I put here the link. There is one for Spanish partners and another for Portugal, where here you can click and you can go and find a lot of useful information about the different tools, documentations that you need for your daily work with Xylem. So anytime you have you want any suggestion or improvements for this portal, please reach out directly to Germán Álvarez or to David Garrido to support you on that. Or you are missing a specific document, because the idea is that everything should be in such portal rather than sending emails and emails. Okay, a list of documentation and tools that you should have access is, of course, the Solver tool. So it's important that you are registered if you are not already. Here you have the link. Okay. We will provide you, and I will explain later on, the price list that we for mixers we're using two price lists. In the near future, we will see how we can support you better on this with a new tool that we are developing locally, or because in the case of the mixers, even the Solver will provide you the local price list in Portugal directly when you do select and you do the configuration of the mixers. That Kindle will show later on as well. Also, I don't know if you have, or all of you have, the quote tool. That this is a specific Xylem software tool in order to do the quotations. And that this is connected, but not in the case of Portugal, with the ERP systems. And you can find also there are the part numbers and the description of the equipment. And then, and I think this link is also very interesting and very important. Many times when you are missing some technical specifications for a specific pump or a specific mixer, or drawings or operating manuals, all of such information is on this link. So you can click here and filter by brand, by product, and by model, and you can obtain a lot of technical papers and documentation. And the aim of this training is to provide you as much autonomy as possible. So you can go by your own and you don't rely on Xylem to answer you by email specific questions that could be already in this portal. Bidding rules, this is very important. I guess that you have access a kind of a list of what are clients that are managing by Xylem directly. I'm not sure how all of this is organized in Portugal. So in case of that, again, contact your account manager. And where not to design bid directly from partner, something that we put some rules that this is something that of course we can do exceptions. And this is just to better coordination with Xylem. Is when we are talking about project phase, when we are a consultant and we want to specify all the Xylem products that perhaps some of the products you're managing some of the products, but not all of them from Xylem. So that's why it's important to be coordinated during this phase and also in the bidding phase, because we have multiple contractors from different regions and so on, and that's why a mix of the different clients. So in this way, during the bidding phase, in a tender phase, sorry, so the translation was not done properly. I will change it. It's not bidding phase, it's tender phase. When we have a lot of contractors bidding for the same project, that this coordination in theory will be managed by Xylem. And when the project is awarded and we are in the purchase phase, for some specific designs, like when we have a racetrack, that we will explain what is this later on, but it's the typical biological reactor that is like a loop, where you have a combination of mixes and diffusers. This is something that the design and quotation or pricing should be done by Xylem, because it's very important to take into account the aeration grids design, that this is something that we are responsible for, not the partners. Also, there are specific and special applications that I will also talk later on, moving bed and granular activated sludge. That is important that you contact us for doing the design, and also for some specific biogas and slurry applications that also demands specific and special designs. And also, as I said before, if there is a project with other non-exclusive partners equipments, like could be blowers, could be UV, Leopold or Ozone projects, is something that you have to contact your account manager to coordinate such project. And as I say, the points 1, 2, and 3 are exceptions, but you have to contact your account manager and get his approval. And the point number 3, sometimes we can decide even that Xylem can do the design of these special applications, but that doesn't mean that Xylem will quote it. We can also agree that even if we do the design and the pricing, let's say, you can sell it. Again, all of this is just general rules, and we can, of course, apply exceptions in order to have a win-to-win business with you, of course. Any comments? I cannot see if you raise your hand, so please talk directly. If we start now discussing on talking about the general concepts of mixing, we are different applications, or 4 main applications: mixing a chemical into the water, let's say, or fluid, avoid this kind of currents preference. Also, when you have some kind of stratification because of the temperature. But the main, and where 99% of the applications for our mixers, and I would say to suspend particles, let's say, in a tank, and mainly on biological reactors.
and that also is 90% of the times. And the reason that why we need in a biological reactor to maintain the biomass or the bacteria suspended, because the bacteria are the ones who are degrading the water, the nutrients that we have in the water, and that's why we need the bacteria are in the whole volume. Because if you have the bacteria just at the bottom, the bacteria will consume only the nutrients of the water at the bottom of the water and not at the top. For example, all of this water will not be treated because the bacteria are not in contact with this volume of the water. And that's why when you don't have aeration, because with aeration you can mix as well all of this, you need mixers. Okay, and that's why that I will comment later on in biological reactors, in anoxic zones and anaerobic zones, that you don't apply oxygen, you don't introduce air, you always need to install a mixer to avoid the sedimentation or the biological flux of bacteria. Very important, because even today, many consultants and customers are still designing with the wrong parameters, I would say. We have even a book in Xylem we developed and we were providing a mixing handbook. It's, I don't know, 50 or 100 pages. I don't remember. It's quite intensive. That explain the theory of mixing. And so this is just a summary of such a handbook. What is important for mixing is the process requirements, and that these process requirements, it depends of, let's say, the particle size, the density of the particle and other things. And this process will require a specific speed. We call it bulk velocity, because in a tank, we need to maintain a specific or an average speed or velocity in the whole tank. That's why it's called bulk velocity. And in order to keep this velocity, this velocity will avoid the sedimentation of the particles, we need to push and, let's say, a thrust from the mixers. Okay, so this is the parameter that we need to design a mixing tank. Of course, the tank geometry is very important, because if you have a lot of obstacles in the tank, this will request more thrust, okay, more push from the mixers. And then when you obtain these newtons of thrust is when you have to select one or two or three mixers with different models in order to be sure that you produce, or your mixers produce, more thrust than the thrust required by your process. Okay. Why we are explaining all of this? And we have this also the equation, because in many projects you will see that it is specified 5 watts per cubic meter. And this is our own design parameter, and this is very important. And we will explain later on this. So it's very important that you understand how to, let's say, design properly a mixing system, that because many competitors even, they don't know it. And something that is very important and critical is this speed, this bulk velocity, because impact a lot the thrust, and it's a quadratic formula. So this means that, for example, if I increase the speed by 10%, so instead of 0.1 is 0.11, let's say, or from 0.3 to 0.33, let's say, it requires 21% more thrust. So 10% change of velocity requires 21st more thrust, and then means 21% of more power, let's say, in some way, with the same efficiency from the mixer. Okay, so that's why this velocity is very important, to be precise.
David, one question. We sometimes have clients that require influence area instead of the thrust. This cannot be directly translated the thrust to the influence area. How we can work in that kind of requirements from the client.
What do you mean influence area?
I don't know if you are familiar with, for example, Fagiolati mixers or tools. Sometimes instead of the thrust, they give one
flow rate. You mean?
It's like a candle in front of the mixer, like a bulb. That is the area that the mixer will do the mixing, the agitation.
Yeah, I think that is. Sorry,
I think he means the where the jet from the mixer can reach, which area can cover. So for this we have kind of a formula, but it depends on the shape of the tank.
Yeah, Tina will explain such a specific limitation of the mixer distance, let's say. But this is not even a design parameter, I would say. And from the design point of view, the point most of the times the point that we see is that this energy per cubic meter parameter, sometimes even they specify the flow rate of the mixer. That is also a wrong design, but this is should be the real design. And if you have the tank geometry, because this is very important for doing all of this, you can convince and you can explain to the customer why you need this thrust for such a specific tank shape. Okay. And of course, if you need
thank you.
technical support, specific support for a specific project in order to help you to convince the customer, you can count on us. You can contact us.
Okay, thank you.
Because something that I learned from my experience in water treatment is that there is almost no one project similar or copy of another. So almost every project is a complete different world that you have to approach in a different way. So in order also to explain to the customer about such a wrong design ratio, we have these two formulas that explain how the push or the thrust of the mixer, and then the performance, the efficiency of the mixers. And there is a relation with the number of the speed of the blade, the rotation of the blade or the propeller, and the diameter of the propeller. Okay, so at the end, the most efficient mixer is the one that provides a lot of thrust with low energy. And to achieve this, that's why we have the banana blade. That is a mixer that have a big diameter of blade, and the speed, the rotation, is pretty low. And we can do this because we have a gearbox here. So that's the way we reduce the motor rotation speed and to much lower rotation speed. Okay, so in the banana mixer this is the reason why this mixer is 5 times more efficient than this one for the same application. And here we did a simulation of the same shape, or tank shape, rectangular shape, length, width, and depth of the water. As you can see, it's exactly the same shape, exactly the same volume, and we designed for the same velocity. And what we change only here is the model of the mixer. So these ones are the banana mixers, and these one are the compact mixers. These one are this, and these two are similar to this. And here is the real efficiency of a mixer, is how much thrust I give, I can produce per kilowatts of energy consumed. And as you can see, this mixer can provide this efficiency, 1,300 newtons per kilowatts. Meanwhile, the cheapest one, that is the compact, this also is very important to know that the compact are much cheaper than these ones because they don't have gearbox, they are much smaller, and so on. This one provides this efficiency, meanwhile, this only 300. Okay, so it's almost 5 times more this one of efficiency than this one. And this is the kilowatts, the energy that you have to consume for the same volume, okay? And this is the ratio. And that's why we say always that this ratio of watts per cubic meter is not the right design. Because for the same from the same volume with a compact mixers, you can consider like 5 watts per cubic meters, but if you install a banana, the ratio will be 1. And this is the reason why in many plants, existing plants, because we have this issue in Spain, and I think in Portugal is quite similar, not in Germany, for example, that in many biological reactors where we have, it's not a racetrack, you're not doing a loop, because in this kind of biological reactors, you always install bananas historically, but you can even use compact mixers there. But historically, the people always consider bananas for such a racetrack. But in such biological reactors where you have a big tank with compact mixers in big wastewater treatment plants that they have to reduce nutrients, they have to remove nitrogen, and they need these anoxic or anaerobic chambers. Many big plants they have these compact mixers installed. So a good way to convince a customer for energy efficiency improvement, you can propose to replace this by this. Okay. Also very important when we're talking about thrust, that is how to measure the efficiency of a mixer. This thrust, because I can say that one of my mixers can provide, I don't know, 1,000 newtons, let's say, but how do you check it? How do you check it? How our objective, let's say, customer can test this? So there is an ISO that specifies how to measure this, and we have in Fleet in Maboda in Sweden, our factory have this bench test where you can even test the mixer thrust. Okay, and there is a rule or a regulation that describes how to do this process. So all our specification of our mixers, the thrust that you see in our technical specifications, are following this international standard norm. Something also important for you to understand is that if we're talking about biological reactors, that is the main application that we have for mixers. This is a conventional activated sludge plant where you have a biological reactor and then a secondary clarifier where you, let's say, split, let's say, or separate the sludge from the treated water. The treated water goes here, and here you have the sludge that almost 100 of the sludge is recirculated to the biological reactor, and the other sludge is going to the sludge treatment line. Okay. So we need some we need the mixers in the biological reactor, but usually when we as I said before, when we don't have aeration, there are some chambers, anaerobic and anoxic chambers, or even facultative, where you need to apply mixers. But there are some specific and non-conventional, in some way, biological reactors that it's important that you are in some way familiar with this. That is, for example, MBRs. Okay, MBR is a membrane biological reactor where instead of using a sedimentation basin, you use UF membranes to separate to split the sludge. And for these applications, and this is why this title is in green, means that from the design point of view of mixers, you don't care. You can do the design of an anoxic zone if the customer have an MBR. It doesn't change anything. Okay. So the design for a mixer for a conventional biological reactor and an MBR is exactly the same. It's just the dimensions of the tank. That's all. For SBR, it's the same. You can in some way even adjust something because the SBR is a sequential batch reactor, which means, and that's why in Xylem we have a biological solution for this that is called the IKEAS, the ABJ, and all the process is done in the same basin. Okay, so this is a kind of also special biological reactor where instead of having one place or one zone for the biological reactor, one zone for the setting tank, everything is done in the same basin, okay, or tank. So here, if you have to install mixers, whatever, you don't need to do some specific or any special design for the mixers. You need to talk just with the client to understand the water level difference, because of course, with the water level difference, you don't need the same thrust for this volume than for this one. So it's important that the customer tells you, in the case of SBR, which is the water level that you have to take into account to design the mixer, okay? And we can talk later on about this. Even for this application, you can apply the variable speed mixers, because like the Concerto that we will explain later on, some of our mixer models, they include a BFD inside. So you can also adjust the speed, sorry, the thrust of the mixer. But usually it's not worth enough to do such variables adjustment here for SBR. Then we have, and this is also important, that moving bed is wrongly translated. I will change it before I send to you this presentation. It is called also MBBBR or IFAS. All of this is more or less the same. It's when you have a Barica reactor and you put this kind of carriers or plastic media in order to improve the nitrification process of this Barica reactor, okay? And this is important for the mixing point of view, because if you design a mixer and you have these carriers in the mixing chamber, we need to select a special mixer, because this plastic can damage the conventional mixer, okay? And that's why I say at the beginning that when you find this kind of process, please reach out to us and we will help you to design such a specific mixer, okay? If, and this can happen as well, like you can see in this picture, you can have these carriers in these aeration tanks, but not in the mixing one. If you don't have carriers here, you can design a conventional mixer by your own. You don't need to contact us. But be sure that if you see this kind of Barica reactor, please be sure that you don't have carriers in this chamber. Otherwise, contact us. Because for mixers and with pumps, or of course with any product, if you do a wrong design or a wrong selection, it will cost you more time, more money, let's say, to solve later on the problem that we could cause. So that's why be careful with all of this. Before, if you have any doubt, please contact us. In racetracks, as I say, it's red, and you should not design by yourself, because it's important the synergy between the mixers and the aeration grids. And by now, the aeration grids design is in our hands, and that's why anytime you have this specific design, please contact us. And then another specific Barica reactor or different Barica reactor is called Nereda. I think in Portugal you have some plants already. I think Acción Agua is the distributor of this technology, and it's called the granular activated sludge, where the sludge, instead of being small flocks of bacteria, they create a big flock and quite heavy. It's almost like a carrier in terms of density. And that's why when we have this also special Barica reactor, we need a special design for the mixers. And that's why it's in red color. So anytime you see or you need to do a design of a mixer for this specific Barica reactor, please contact us. Any doubts? Any questions? Okay. Our products, I guess you already know all of them. Just to inform you that the 4610 is phased out, so we should not continue promoting. It has been replaced by the 4620 because we did a kind of, like in the past, we did an exercise of simplifying our portfolio in order to be more profitable, let's say, and not having too many models. Well, that's why we try to reduce them. We don't have IF3 motor on the compact ones, okay? But we have it on the Banana, okay? And we have the fixed speed mixers portfolio and the variable thrust mixers that we have the BFD integrated in the mixer. And we have compact mixers, as I explained before, and then the Gear 1 or the Banana ones. And the same with the integrated BFD, which we have the BFD or the variable thrust mixers with the compact mixers and also with the banana mixers. Okay, so we have all of these models for the compact one and all of these for the banana. For the integrated BFD, just for your information, that I think is very important, all of these mixers includes equivalent EF4 motor, and we have 2 models for the compacts and 1 for the banana. Okay, and something that is very important when we want to specify these mixers, because we are unique in the market as Concertor, our competitors don't have this kind of mixers, and that's why if you can specify this kind of mixers, or you convince a customer with this kind of mixers, you don't have a competitor for this. And the only way to compete against us in some way is that the competitor use their conventional mixers and they have to install a BFD. But our BFD is already in the mixer, so they have to install and find in a control panel enough or create even a specific local panel with a BFD in order to simulate or do something equivalent as our mixer is doing. Like Concertor, as far as I remember, we have different control systems. The basic version that is just variable speed mixers that from factory we adjust the power, let's say, that we want for such a specific mixer, or we can adjust the mixer thrust with this gateway and without any automatic control, I would say, in this kind of solution. You can just adjust it by yourself, or here that you can even connect with specific sensors and so on, and everything is done automatically. Again, anytime that you want, because the first way to learn is learning by doing. Anytime you have these BFD situations or scenarios, please also contact us so we can help you better to select also the right gateways and control systems for when you want to sell these kind of mixers. Again, these kind of mixers are very important to promote because we are unique. And it's the best way also to improve the efficiency of a mixers that also I will explain later on. Okay, if we are talking about the variable thrust and why we need variable thrust is that, as you probably know, in many biological reactors, when you have a mixer, the mixer is not like a pump that you usually a pump. It depends of the configuration, but you can adjust a pump in order to provide more flow rate and so on for the same pressure. Here, if we have a mixer in a chamber, such mixer is running at full speed all the time. Okay, but from the process point of view, you don't need that such a tank or chamber is full mixed all the time, because sometimes during the night, for example, you don't need a complete and perfect mixing chamber. You can turn down or adjust the thrust of the mixers, because even if you push or let's say reduce the thrust of the mixers, you keep, let's say, enough suspended biomass in the tank, okay, and you are consuming less energy in the mixer. And something that where this variable thrust has more impact is in the racetracks. And the reason of this is because the aeration of the diffusers, when you are aerating this chamber, the air is a kind of brake for the velocity of the racetrack. So, for example, if you are now pushing with this mixer, is pushing always at the same thrust, let's say, the velocity of the racetrack will change if the aeration is increased. So if you increase the aeration, you will reduce the velocity of the racetrack. And that's why when we are doing a design of a racetrack, and that's why it's something that we want to keep at Xylem, but we will see in the future, we also allow you and provide you the tools to do it by yourself. When you increase this aeration, we obtain different thrust. So for minimum aeration, or without aeration, because sometimes in some plants the people are playing, let's say, with a biological reactor. Sometimes they turn off the diffusers, so the only obstacle here are the grids physically. Okay, this is already an obstacle for the velocity. And sometimes during the night or when they have less flow rate coming to the wastewater treatment plant, they need minimum aeration or medium aeration, or when we have the peak during the morning that you have a lot of ammonia and a lot of BOD coming to the wastewater, you need to increase the aeration of the diffusers. And for these 4 situations, you will obtain 4 different thrusts from the mixer. So that's why for the racetracks it's very important the variable frequency drive. Okay. And I will show you an example. And then we have another important impact on this design that is called the horizontal flow effect. The horizontal flow effect is in a racetrack. For example, if these are the aeration grids, okay, you are supplying the air from here, from the bottom. All of this is the water going from left to the right, because of here or wherever you have a mixer pushing the water in this direction. Okay. So if you design a conventional mixer with a conventional thrust and a conventional velocity, you will have some problems at the inlet and the outlet of the aeration zone. And you will have this kind of vortex creation here. And this vortex, what it's doing is, as you can see, this is the direction of the vortex. And what the vortex is doing is that all of these bubbles in this zone are going up much faster than these ones. So the contact time of this bubble in the water, as their speed uplift velocity is much higher, the contact time is less, and they transfer less oxygen from the bubble to the water. Okay, and that's why this design have a negative impact on the aeration efficiency. And a way to break in some way or to balance the impact of this vortex is to increase the speed of the mixers. And if you increase the speed of the racetrack, you will neutralize this phenomena, this vortex, and you will improve the aeration efficiency, which means that, and this is a kind of result that has been tested, that if you increase the velocity, you can improve the aeration by 10 or 20%. And you can save like 15% of energy, because of course, if you push at much higher velocity, you will consume more energy in the mixer, but you will save much more energy on the aeration, because the aeration consumes always more energy than the mixers in a wastewater treatment plant. Okay. So anytime that you have a racetrack, and that's why also this kind of design, as it is much more complex, is something that we want to do in Xylem. But we wanted to show you this because if you are going to talk with customer and helping us to sell more mixers, and also for this is also useful for you, the BFD mixers are much better to sell on racetrack application. So anytime you see a racetrack, there is an opportunity to sell BFD mixers. And I don't want to spend too much time, but this is an example that we use a fixed speed mixer, this conventional banana. We have a fixed energy consumption, 7 kilowatts. But if we use a variable thrust mixer, the 4320, we can adjust the consumption of the mixer depending on the aeration. And then you can save even 40% of energy. And changing the mixer from the conventional banana to the BFD banana, it can be only 15% price increase. And you can deliver to your customer 40% of energy savings. And again, this is something that only Xylem can do. The competitors don't have this kind of mixers. So that's why it's very important that we convince our customers with this type of variable thrust mixers. Even in a plug flow biological reactor, that is those biological reactors that you don't have the racetrack, this kind of loop. Even in this, I imagine this is an anoxic chamber. You don't need as I said before, to mix this chamber 100% perfect. Even if you mix this 70% of the biomass is a good mix, perhaps it's good enough during the night, and you can achieve the same effluent requirements in the wastewater plant, and you can reduce the energy of the mixers. This, of course, is more useful, I would say, and it makes more sense to apply and to suggest when we are talking about the big biological reactors. Okay, in a small one, don't spend time on this. Also very important, when we are trying to convince a customer, and this is a clear example that we have in Spain, this is the wastewater treatment plant of Bilbao, north of Spain, capital province. It's a huge wastewater treatment plant. As you can see, the size of this biological reactor. This is a plug flow biological reactor. So this is an anoxic chamber, huge one. And in many plants, they are using compact mixers, a lot of them. But in this plant, the end user preferred to use banana. And now we are selling even the banana with BFD because it consumes much less energy than with the compact mixers. And you can even use, it depends on the size of the banana, even the conventional guide bar that we use for the compact ones. But what is important, of course, is when you install the banana, you have to be cautious with the distance from the banana to the wall. Okay, that with the compact mixers is not so important because the blade is much smaller, but with the banana, and that's why also the position of the banana is very important. Sometimes we need to do some kind of let's say, extension here in order to install the banana far away from the wall, because there are some distances that we have to respect. So just for information, when we're talking about a banana with a blade diameter below 1.4 meters, we can use the guide bar. Otherwise, we have to install the tripod installation model. Another example, but again, the main one is the racetrack, I would say, and the big anaerobic anoxic chambers is when we have a sludge storage tank that the customer is asking us to install or design a mixer. And for example, if for the sludge, the concentration of solids is so high comparing with a biological reactor, we are talking now about when just in the sludge treatment line, we are not talking about the biological process. In the biological process, you never reach this kind of concentration. But in the typical sludge treatment line of a wastewater treatment plant, you can achieve concentrations about 2%, which is equivalent to 20 grams per liter. And sometimes they are mixing different sources of sludge, and that's why sometimes the concentration of the sludge in such storage tanks are changing. When we're talking about the concentration, about 2%, the thrust that you need is changing based on the concentration. Below 2% or 20 grams per liter, the thrust is the same. If it's 1%, 0.2%, is the same thrust, but above 2%, because it behaves as a non-Newton fluid, you will request different thrust. And that's why here at 3%, 5%, same volume, 6% or 10%, the kilowatts or the thrust of the mixers is completely different. And if you have a variation between 3 and 10% of concentration of the sludge, means that you need 10 times more energy or 10 times more thrust. Also, sometimes customers don't trust in our design because they think that our design or the mixes that we are offering, it seems that they are not big enough, let's say. So some way to justify a customer that our design is good enough is measuring the velocity in the tank with the different sensors, or the homogeneity of the solids, that is to measure the concentration of the solids in different points and different depths, in order to convince or to show to the customer and demonstrate to the customer that we are mixing with a confidence of plus minus 10%. So this means that if you put different MLSS sensors to measure the solids in different points in a tank, the difference between the sensors cannot be more than plus minus 10%. This is something like kind of process warranty, but it's very important that if you need to convince a customer with this kind of approach, we are telling you that we can do this, but this should be very special, and you should never offer this without contacting us before. Okay. And also the try and buy. Sometimes, for example, like Concertor in the past, and now with these BFD mixers, sometimes the best way to convince a customer for a new kind of mixer is to test it. So if you want to apply a kind of try and buy for these BFD mixers, is something that perhaps we can do. But before offering to the customer, if you see this possibility, please also contact your account manager to validate it. Here are some positioning recommendations. Again, I think the best way of learning is that the first time that you have this situation and you are not sure how to position the mixer for the customers, please contact us. There are some kind of guidelines like this one that the mixer should, the position of the mixer should be 1/4 of the width of the tank. Okay. If you have two mixers in the same position, because when you have two mixers, you can install them in different ways. This one, this one, this one, and this one. All of these are valid. What you are looking always is that you push the water to create a kind of loop in the water like this. I don't know if you can see my mouse. Okay. You never position a mixer to just throw the water directly to the opposite wall. This is the wrong position. It has to be in this direction to create a kind of loop. Okay. And in the case that you want to install two mixers here because of the access for the mixers, you only have this place instead of typically, I would say perhaps this is the best preference to position two mixers in a tank. But again, you can do it also like this. This is the position guidelines that you need to comply with. Also, it's less common, but also we have also circular tanks. So again, I think that the best way in order to learn all of this is case by case to contact us. This is, I would say, much less frequent, not in industry, I would say, but 90% of the applications are the previous one. And also, as I said before, for the racetrack, please contact us, because for the racetrack, there are a lot of different positioning, not just the mixers, even the aeration grids that we have to be use. And this is very important because this is perhaps the most complex application for mixers, because if you don't do it properly and you don't follow these distances, then you can have vibration and problems with the mixers. Also, this is similar to the racetrack. It's a combination of circular and racetrack, let's say, but it's less common. And that's all from my side. Any questions? Otherwise, I will hand over to Kinda to explain how to use the design and selection tool.
Sure. Okay, good morning, everybody. My name is Kinda. I work now for WSS segment as a business developer, but in the past 8 years, almost, I was like working with mixers. So that's why now I'm doing the part of the selection of mixers in the solver. Okay. So I will share my screen. We will be switching between two documents. The first one is this, the guide, design guide, okay, for mixers, and with the tool, the solver tool here. Okay, so I guess most of you have access to solver team. solver tool, I think. So yeah, if not, you need to register. So you register. Oops, here I will switch. Here we start so you need to go to this link. If you don't have it, I think David as well, he mentioned it in his presentation. Then you have to, do you want to register? You have to contact Domingo to ask him for access to the mixer design. Even if you have now access to the solver, you might not have access to mixers because some limitation is there. So Domingo should allow you to be able to enter to the mixer design as well. Or another thing is jet ideator as well. And if you contact Domingo, when he come back to you, I'll tell you that you have access. So then you are really have access to this solver tool. Okay, so you start from here, need to register. From my side, I am like an internal resource for Xylem, so I go with another type, okay, of access. Here we start, okay, so the first one, you have to open applications by application or by product type, by search. Or we usually use search to be able to design for the conditions we have, okay? So you must do default to this path, search and get started. Okay, all of this is here. But before I go, I will just show you something. Here is a general concept of mixing, is what David was explaining. It's like just short part of it, okay? Just like summary. So the wrong concept to design with watt per cubic meter. So this is like summary here, just for your information, okay? And then like a summary of our portfolio, Xylem portfolio from the mixer. It's like divided by 3 types. Compact, which is the smallest one. Okay, you have the conventional and the one with VFD, which is IE4. Okay, you have like the range of the thrust we can offer with this. In the compact mixer, we don't have EA3. We don't have IE3. Sorry, it's between the Spanish and English sometimes. I mixed. IE3 is not available in compact mixers. Meanwhile, for the mid-size it's like 4650, 4660, and 4530. 4530 is only available in IE3, for example. Okay, so this is kind of summary, what we have. The banana, if we have it in 2 or 3 blades, here always we have 3 blades, what kind of material we have. Here I mentioned that the 4410 now only available in IE3. In the past, it was like we have the standard one. Okay, we have like conventionals, then we have like without IE standardization and with IE3 now. Okay, so this one for the banana. But 4410 in this initiative of like the simplification of our product, so the 4410, it was like out of our portfolio. 4410, the standard one. Okay, so here you can like consult to have like an idea what we have in our portfolio, and also installation type, if it's with guide bar, with cantilever, or with a tripod. Okay, so we go to the tool again. Okay, here how to get the access as we explained, and here is the get started. Okay, so here we don't have anything now so we need to add the product. So we go SR, and you have 1, 2, 3, 4, 5 types. So I will repeat it 5 times to get all types of mixers. So now I have 42 and 43, which is IE4 with VFD, integrated VFD. This is the variable frequency. And 44 banana, 46 compact, and 45, this is the mid-size with IE3. Okay. Here it's explained. Then you have to add SR products, repeat the step 5 times to have all the models. Okay. Then we go, now we need to select the tank shape. If it's circular, rectangular, racetrack, or closed ditch. Okay. As David explained, if it's racetrack or closed ditch with diffuser, so these Xylem application engineer will do the design for the time being, okay? Because it's usually combined with diffusers design as well, okay? The diffusers also should be considered in this design for the mixers, okay? So you have first to select this. For example, if we select circular, even you have to select which type of circular tank, because might be standard, might be you have like annular one, or with like slope in the bottom or without. So it depends. Okay. For the rectangular, the most direct one, length, width, and depth of the water. So here you have rectangular, you go to length, width, and depth. Here in the guide, I already included the racetrack. Okay, select the racetrack type, enter the straight links and the channel widths. So here the tool will guide you what I need from your side, and select the span type. This one we call like vein or span type. Okay, because this is very important. For example, if you can see here, when we add this, okay, central guide one, you have the paint losses 1.2. Look at this example. Without adding this, this is also the paint losses, okay, but it's in Spanish, pérdida de codo is 3, it's more than the double, okay? So this is very important parameter to add also. Even we are doing this, but I just keep it. Some people will have curiosity or will need to learn more, so they can do their draft design and confirm it with the application engineer specialized in this, okay? Also for the, I can show you here. See? Also, sorry. Okay, here, tank shape, here one, okay? So mostly it's this one, so you have to put if it's like this or like this, or no, there is no guide bands, or there is central one. Okay, so you can see that the losses is changing. We go, also we have the closed ditch. Sometimes we have different one. So this is special. You have to enter the total links, where the water will enter, where the water will get out. So what is the water path, I would say. What path will the water will flow between the inlet and the outlet? So you calculate the total links, then you put the widths of each channel and the depths of the water. And here you need to add how much like bends you have, the number of the bends you have. Okay, so this is not in your now responsibility, but I will keep it for the guide for the people who wants like to have more information about it. Okay, so we go here and we go to rectangular. For example, I will use like 30, 18, and depths of 5. For example, here we can put okay, like chamfer or anoxic 1, anoxic 1, just to have it in the report later. Okay. So you go, and here you have to select which kind of application you have. So biological treatment, mixing, I will add mixing here with the same. Okay, or sludge handling. For the time being, we will use the 3. Biological treatment mixing, sludge handling, and manure. Okay. 99% from the application might be sludge handling or biological mixing, or the majority is biological mixing. Okay, so we go to biological mixing. Okay, the first you have from the drop list here, you have to select if it's like chamfer with no aeration, anoxic and anaerobic with no aeration at all, which is our application normally in anoxic and anaerobic zone without any diffusers, aeration diffusers in the bottom. Or for example, we have diffusers. This is what we call facultative zone. Okay, so here we have diffusers, but it's turned off. Okay, or it's like aerobic aeration, then the mixer and the diffusers will work together. Okay, but when this one normally for the racetrack application, which we say that will be done from Xylem application engineers. Okay, so we have to choose between them. I will now concentrate in anaerobic or anoxic zone. Then we have all steps is here. Okay, so I'm just switching between them to show you how to do this and how it is registered. Okay, then the type of pre-treatment, as David explained, that the pre-treatment will define the size of particles will reach the biological basin. Okay, so if we have a screen less than 10 millimeter or screen more than 10 millimeter, no, all of them screen less than 10 millimeter with primary or without primary. Okay, so if I put 10 less than 10 millimeter, no primary, you can see recommended average velocity is 0.28. But if I put that there is primary sedimentation, 0.25. And if I put a screen is less than 6 millimeter, you can see it's 0.22. Now this is the recommended average velocity from the tool. From experience, I can tell you that the customers doesn't like any design less than 25. Okay, so even all the wastewater treatment plants have a screening at the entrance less than 6 millimeters. So if you ask, so it's always like this. Okay, so always 5 millimeters or less they have. So it's mostly this. But we can say, okay, you accept the recommended average velocity, yes or no? You can say no, and you put here, okay, even if you are recommended 0.22, I will need 0.28 because I know my customer will not accept less. But normally it's like 0.25, it will be accepted. Okay. I don't prefer to get this, actually, no, because in the report, if you put accept recommended average, no, then in the report, it will appear like velocity guarantee, no. In reality, we don't give any velocity guarantee because this is like a big deal. How to control the chamber, how to close the entrance, where is the, it's like many factors should be considered before we give a guarantee, and the sensors of the how to measure the velocity. It's like big things. So we tried many times, no, few times actually, to provide this guarantee, but it was like headache. Okay, so just to avoid this, I will normally I use this one to just get the recommended output, yes, and then the velocity guarantee will not be showing in the report. In reality, all our competitors, they don't give velocity guarantee, neither us. Okay, so the third item we should identify if the outlet location in the tank is top or bottom. Here, water outlet location. Okay, so if it's in the top, look, now we have recommended velocity 0.25. So we say in the top, but if we tell the program that the outlet is in the bottom, so it will reduce the recommended velocity. Why? Because if the outlet in the top, we need to avoid clarification. Okay, sometimes the water or the liquid, whatever, so clarified at the top, okay, at the surface. So to avoid this, we need like to overmix. So it depends on this. There is velocity recommendation. For example, it's bottom and now 0.19. In the top 0.22. Okay. So we'll keep it like this as a primary, the top 0.5. Sometimes we can size like the mixing more accurate. Here when we put size for inflow mixing, okay, but in this kind of configuration, we will need the inflow, the flow rate coming to the biological basin, okay, the recirculation, internal recirculation, and external recirculation. Okay, so you might have like 100 cubic meter per hour. The internal recirculation might be another 100 if it's 1Q or 2Q, so another 200. So it's like 300. So it's like you can put here 100 here. Here it's a little bit. It's like the activated sludge. The external might be like 25. Might be, depends on how much sludge age, this calculation. And then, for example, here 200. So, like the total, they will but it's cubic meter per second, and it will not be like this. It's like here, this cubic meter per hour. Okay, but this one we need a lot of information that usually are not available. Okay, so very few times I designed for these conditions. Actually, it's more accurate. Yes. We want to be like accurate, should be designed like this. So it will be, now you see view result or next, and it will take in consideration this one. But normally we don't have it. Okay, we just have the tank dimensions and if it's like anoxic or oxic zone. Okay. This one, based on the above data, it will give you so you can reject or you can accept the recommended velocity. Then a size for mixing, this one, the rectangular one, the rectangle. So this is what I explained. Now, if you select that aeration, okay, if you select aeration, even if it's not your responsibility, but I will explain it a little bit. So the program will ask you what kind of aeration you have. So here you have to enter the bottom area covered by diffuser. So if you have like racetrack, so you have to see what area is covered by diffusers and enter here a number of diffusers. Okay, and then the percentage will be calculated. If you put here like it was like 10, so the percentage will be calculated. You need to add one on another. So the number, if it's like 15, then you need the flow rate per diffuser as well. So this depends. Okay, so too much information here. You need to be aware about the design of diffusers. Might be not sanitaire 9-inch diffuser, might be another type of diffusers or managed diffusers, and you can configure the diffusers. So you need to select which kind of diffusers, the area of the diffusers, look, add new, and you can select the area, active area. It's like more advanced, but you can discover it yourself. It's not difficult, okay? If you select here anoxic zone, like facultative zone, what we call in English we call it swing zone. Sorry, just if you don't understand any word I say, just stop me and ask, please. Okay, this is, we call it in English, swing zone. Okay, sometimes it's anoxic, sometimes it's oxic. So here, for example, will not ask you about the flow rate of the diffuser. Will ask you how many diffusers, how many diffusers, the covered bottom area, and the number of diffusers. That's it. Okay. Here we have some advanced search criteria. For example, you know that you will not use at all the banana, so you put, I just need the compact. So in the search, you can see how now we have 14 results. If I put search, now we have 9 results. You can see. Okay. Minimum number of mixer. I know that the customer will not accept any design with less than 2 mixers per chamber. So I put, okay, 2. I know that it's a little bit, I don't trust the information or the data provided by the customer, so I might specify minimum thrust margin. Okay, so I need all the mixers that don't give me 5% of thrust margin. I don't want to see it, so I put minimum 5%. Okay. Mm-hmm. So, and then we have if it's like standard or ATEX, okay, if it's like high chrome stainless steel duplex, so will not show you the models that, or the mixer model or mixer type that doesn't have stainless steel duplex, for example. Okay, here we keep it standard. Or I just need without jet ring, so I put just without. So the results will not show me with jet ring. Then if it's 60 hertz, will not be for Portugal, but for if you are designing for, I don't know, Brazil. Minimum submersions, okay. To respect the minimum submersions for the mixer, because we need for each model or each type of mixer, we need minimum submersions to make sure that the cooling of the motor is correctly functioning. So sometimes we need, okay, no, okay, but here normally, and if you would know, so they will tell you, okay. And so all of this, it's like advanced. Normally we don't use it, but if you want, I will wait a little bit. I will accept someone. I don't know what it is.
I'm doing that, Kinda.
Ah, okay. Okay, so now this, just to concentrate about the type of biological, the screen, and if it's top and bottom. This is most probably the parameters that you need. Then we go view results, and here we can see results. Okay, so now let me see how it's the guide, how it goes. Okay, here all what we explained about the designing by the flow rate, the diffusers, the area covered by diffusers. Then okay, I will go with the design tool. Okay, So we go now. Later we will come back to the search. Now I will show you sludge handling. Here, if we are mixing the sludge, okay. So in this case, we are not entering. We already entered the tank shape, okay, and the parameter. But now we are saying that it's a sludge. It's not biological treatment. It's a sludge when it's like more concentrated, okay. We need to specify if it's primary sludge, chemical sludge, mixed sludge, which is primary and secondary, or biological. So because biological, it's like after the biological basin, okay, from the secondary clarifier. Okay, normally it's mixed sludge. It's like mixed between primary and secondary. Okay, if it's digested sludge after the digestion of the sludge in the sludge line. Okay, so we have most of them. It's like mixed sludge. Here, what we need, it's also we are not doing digester because here it's like another type. It's like more biogas. Okay, here it's like sludge storage or holding tank. Okay, this is the application, the right application for us. The digester is the digester itself, and where we produce methane, and this is like biogas, more biogas. Okay, here we have to put the concentration by weight, might be 2, 3. I think David already explained this, 2, 3 until 12. Maximum is 12, okay, but I will tell you more than 5, so some limits will be available, some limits will be applied to the mixer models, okay, there is high viscosity, they will give you this. Normally we are speak about like 4, 5, something like this, okay. So, and the third one is the manure. Here you have to put it's farming or industry, dairy, pig or poultry, okay, and the concentration by weight as well. Okay, it's explained here. Then you can view the results. Okay, here. Okay, here narrow tank. Here is a slurry. Okay, we select manure, and in the manure you need to add the version 300 or 310, 311 in the Phoenix, okay, but also the tool will show you just the type of the mixers available for this kind of slurry. Okay, we will go back to the biological treatment. Here's the one, and to see the results. Now we are in the phase to see the results. Later I will explain the long narrow tank, okay? So here we have different type of mixers, how to select. Okay, this one I will come back later to it, okay? Okay, so first we have to know these points. First, mixers began with 44 or 43, they are banana type. They have diameter of the plate 1.4 to 2.5. We have 2 or 3 plates. Mixer with 46 or 42, we are speaking, they are compact mixers. The diameter of the plates, it's from 210 millimeter to 776 millimeters. The 4530 is the medium size, is with diameter 1.2 and only available in IE3 800 motor. Okay, now I will show you. Mixers start with 43 or 42, okay? They are adaptive mixer with variable frequency integrated, and this is IE4 motor. The 44 mixers, they have version available in 800, which is IE3. The 4410 is only available in IE3. Mixers with jet ring, not advisable, not recommended for sludge application when long fibers are presented. Okay. By scrolling to the right, you can see the features of each model. Okay, here. So you can see here the application we have. We can filter. First, we can filter the columns. What columns I need to see? So too much columns for me. I don't want to see, I don't know, here the blade angle or whatever, okay? Or the weight. I'm not interested about the weight. I'm not interested about the shaft power because I have the rated shaft power, okay? For example, okay, the efficiency. So you can just arrange it. You can drag like this to change the order, and you can switch on, switch off some columns, okay? This is the columns. Then you can make filters, but the filters, I will make it from here. For example, I don't want to see any mixer, any results with more than one mixer or more than 3 mixers. So each one with 5, 7, so I just put 1 and 3. So you have 1, 2, and 3. That's it, okay? For example, I don't want IE3. IE3, we said that it's 800, no? So I will just switch it off. I don't want jet ring, for example. Okay, I said that all the jet ring, yes, out, okay? Number of blade, this is more about the banana, okay? So for the banana, for example, now we have different models. Then if we want to see in mixer type, what is the mixers available? So we we put, click the right button and use single model selection, okay? You say this, and you have displayed all the 4430 available. Look. Now I will tell him, no, I don't want IE3. And then I tell, I don't want 3 blades. I want to just concentrate in 2 blades. Okay? So you start to on, I don't want a big diameter. So it's like just like 2 and 220 and 2.5, I will take it out. So I'll start doing, because the order will be normally from the more efficient to less efficient. But you start to make your filter to select what you want. Here is now the criteria, okay, of the selection. To select the most economical, now I tell you, the program will order the result from the most efficient to less efficient, okay? And now, normally, our customers are looking for most economical solution, no? So how to find it? I will not go select each one and go to the price list, because this is like crazy. So the minimum number of mixers that a customer accepts. Sometimes they specify that they need at least 2. So we cannot go with the 1 mixer. So if you have 2 mixers, 1 mixer 4630 or 2 mixers 4620, so the 1 mixer of 4630 is less expensive. Sure, so always 2 units from the same type, compact or banana, okay? Because 1 banana mixer is way expensive than the compact mixer, okay? But from the same type, if it's compact mixer, 1 mixer is less expensive than 2 mixers. Then the smallest motor size. So under the same type of mixer, sometimes we have different motor size. So you go and you search to the less motor size. Okay, then you go and you search for the less number of plates. This is only for banana because compact mixer always with 3 plates, but for banana might be 2 or might be 3. Okay, so for banana, if I want the less, but for example, if I go with 2 plates, a banana mixer, then I need to select 4430. And if I allow 3 plates, then I might be able to do it with 4410. And 4410 has motor size smaller than the 4430. So this is the category you have to consider it one by one, okay, with order. Now try to without IE3, always the standard one if it's available, because for the 4410 it's not available. If it's available, go to the standard one if it's acceptable as well from the customer. So it depends to the case or to the application you have, to the customer you have. Now without jet ring also it will be more economical, okay? But in our consideration, we start from this one to this one, so we go in the order, okay? Now, okay, here click to the rectangular to you select and to view the available mixer from the single model. Right click and select single model. This is what we did to see this list, okay? Then here it's explained. Then we can filter, okay, what we say, we can filter between them about the like diameter of the plate. Now, if you have similar selection and you want to compare between them, so you can do it. I will show you how. For example, we will see results. Okay, I will say, okay, I will take this one, for example. I will take 3 from this. No, I will take this one as well. But for example, I will go here. I will tell him use single model. I will take, for example, the less motor. Here's the motor size. You can see it here from the rated shaft. Okay, for example, I will take this one. Okay, so now we have 2. One is 4660 and one is 4650. Okay, so I go to compare. So you have this one where you can see the consumption, the efficiency, the required thrust, the produced thrust, the margin of the thrust, everything. This one you cannot print it, but you can use like this one. I'll take it many times. I just send it to the customer like this to make them a comparison, okay? You can adjust it like this a little bit, make it more, but there is no way to print it, okay? But you can have more, even 4 designs, and you can see what is the reference. For example, the thrust margin. Here we have 7, here we have 9. So here, what is the efficiency? Okay, how much newtons? This is the efficiency that David explained. How much newtons I can produce per each kilowatt I am consuming. Okay. Then we go view details, and these view details now. Okay, here in the details you can see the product information. First is the product information. Okay, here is the product information. 46 as in general what it is. Okay. Here is the information. You may switch to another one if you have 2 selected, okay? You may switch between them. Here we are loading, okay? Here also 46, also the same, it's 4650 or 60, okay? Here will not change, but what will change is here. For example, the motor information, you need the rated current, for example. Also, this one will be different, okay? You can see the difference. You can see the installation, how to install it, okay? It gives you the information, material and coating for each one. You can switch between them. Monitoring and control. For example, if we have one with, I can show you. I will take one with variable frequency. 4230. 42, we said in the guide, 42, that means we have VFD. So I will take also, I lost it, the another one, but okay. Now we have 3 of them. Compare. You can see here. For example, if we go to this one, 42 type. So in the monitoring and control, you know that it has FLS, which is here, might be not standard. You can select it or leakage sensor, yes or not. You can select it or you cannot. But in the 42 series, it's like a mandatory. Okay, this one has a configuration. Then details. Okay, here the application, the tank data, product data. Okay, motor we have. Then you have dimensions. Here you can download whatever you want, the dimension drawing, okay? Like STP or DWG or SECAT file, whatever. Documents, here the IOM, okay? You have the part list, you have technical specification, you have the basic repair kit, okay? Everything, specification. For sludge mixing, you can download it. With this, you can
something
download
that is important here is that such documents that Kinda is showing, I think they, in the solver by now are in English, as far as I understood. But if you go to the link that I showed in the first or second slide in my presentation, in such a link in the TPI, you can find the same documents, but already in Portuguese.
Mm-hmm.
Unfortunately, you have to go to another website, let's say, to find it in your local language, but just for your information. Nevertheless, we are working with the people from Solver in order to also to show in this selection tool even the local price list and the description, better information about the configuration and everything. So in the future, they say some months, you will not need to go to another website or to use the Excel files that I will explain later on. But we are under construction, let's say, all of this. But I think that sooner or later, more sooner than later, I hope, you will have even here in this tool, even the price list.
If you have the price list, for example, as David said, for example, you can see here, 20,000. I don't know if it's because I am internal user, okay? So I can see that this is more.
But this price is the international price list, it's not the Portuguese price list. So please don't use those prices that you see there, because you cannot apply such a price list. Every country create its own local price list. So the prices that you have to use, don't use by now this information in the website. You have to use the Excel file that I will show you later. But in some months, the local price list, the Portuguese price list, will be implemented in Solver, and the numbers that you will see here are the right ones, but not now.
Okay, totally agree. Don't use it, but you can use it to compare which one is more expensive if you are looking for the most economical solution. Okay, so You know that this one is more expensive than this one, and this is the most expensive one. Okay. Then price summary, which is here, so you know that's a support. And if you select the jet ring, for example, I will give you what the jet ring, how much will add to the price, for example, 2,000 or 3,000. So you know, okay, so adding jet rings, it will add like 2,000 to our solution. Accessories, this is good to know. Now, David will show you another tool, but this one might be kind of orientation. Okay, for example, for this one, which is 42 series, if we see my connect, no, there we go. Okay, so you can see that here we can use the model to change the velocity. We have FOP, which is the screen, to use the manual one with like scroll or with touch screen. Okay, so you can see the like item number. Here, when you add it, is to add it to the price. Okay, for example, I will add this. Then you will see that the price. No, I have to save the project first. Okay. And for this one, you know what is the accessories you can add. Okay, it's not added, but you can. It will display the accessories you can add. Okay. Here it's the guide bar calculation. It will give you that the guide bar depends on the water level. I select the water level 5, so it give me that the guide bar should be 6. It will not. We have another one with the 3 meters, and it will not work here. Okay, because we have liquid level 5 meters. Okay, so they will tell you where to install these supports to avoid buckling of the guide bar. Okay, so they will give you, okay, tension and deflection. Okay, within the limit, but normally you don't use it. And here is like the price. Okay. But I don't know if you will get the same exactly display, because this one just orientation. David will show you another tool for the time being to use in this case. Okay. Now you want to print the document. Which one? Okay, so which one? You want to print this mixer. Okay, so we go. Generate, you can generate Word if you want to modify something, or PDF. You're not able to modify anything. But here, for example, we will generate Word if we want to. And also this in English. I don't know if you can, David,
check it.
Download it in Portuguese or in Spanish.
Click again. I think that you can do it.
Okay, let me see.
But only this report, not the.
Okay, look. So let me see if there is Chinese Danish. Here. So we will generate. So you can generate the report, the final report with the local language. This one, for example. Okay, so you have it. You have the specifications, the selection with the tank geometry, the drawings, and that's it. Okay. So here, if we go to the guide, so you can see the product information, design and model data in the dimension tab on the left. You can download the plans, the drawings, not the plans. Okay. In the document tab, you can download the technical specification out, IOM and part list. To download the selection sheet, click print. This is what we did. Document, select, click print, select, the language. Okay, select the language, document, and then you can download it from generate PDF or Word. Okay, then you will use some information from here. Here is the, like what we worked actually, the information that we give to the tool. And now the tools that David will explain after me includes the accessories. Okay, so if it's compact, it's like gray color. If it's banana, it's like yellow color. So just you need to put the model and the water level model, and in the banana model and diameter or plate diameter and the water level. Okay. And the accessories, you go, now he will explain, you go to the tab and you see the accessories for this kind of mixer. Then you have the technical specification, also Excel tool. You have to fill some information. All of this information is here in the selection, okay? Or from the report, I highlighted the information that you needed in the tool that he will show now. This is the tool. Then you go to the specification for 46 or specification for 44, and this is like kind of the specification will display. Okay, so you can take it. This is, for example, for the consulting and companies that they are doing the specification for some tenders. So to help them have the specification modified one, so you can do it like this. And okay, so finally we have the long narrow tank. Before, this is the last step. This is important because sometimes we have something like long, narrow tank. It's like rectangular where the links to the width or depth, the largest between them, is less than 2.5. This is if this formula is correct, so we identify it as a long, narrow tank. This what means? I think this is the question came during David presentation. Each mixer has like distance to reach. Okay, so even if you put here the biggest mixer you have, they cannot reach more than 2.5 from the width or the depth. Okay, because of the geometry of the tank, it will the force of the flow will disappear because of the boundaries of the tank. Okay, so this is the formula. If it's what each mixer will reach, it's 2.5 from width or depth. Okay, this one minus d, which is minus d, it's the diameter of the mixer plate, but normally it's very small. Okay, it's normally very small, even for banana. Okay, so for compact mixer, so the largest one is 0.7. Okay, we can sometimes force one mixer to reach more distance. Now I will show you how to do it in the tool. Okay, but otherwise you need to put two mixers. Now this same tank, what I want to tell you, that this same tank with same dimension, for example, with same links, but with wider width, might be able to design with one mixer. But if the tank is smaller because it's a stretch, so you need two. Sometimes I had a discussion with customer telling me, how you put two mixers for this small chamber and one mixer for this big chamber? I said, yes, this is what I need to put, because this is what I need to design too, because here you have like losses, more losses because of the tank shape. Okay, so how to put it in the tool? How to use the tool for this? We will use this example: 15, 5, and 4. We go tank shape, rectangular, standard. We said 15, 5, and 4. Okay. Next, we'll keep it with all of this. Now we will see the results. Okay, so you can see that always they give us two, all of them is 2 parameters. So now I will go here and no, banana is very small for banana. I will go, for example, 4630. Okay, I will give him use long narrow. You can see that now in the past when our input was not comply with long narrow tank, so this option was like not available. Now it's available. Okay, so you put long narrow tank and they tell you no, we cannot force this mixer. So I go to the next model. I will see if it's with 4640 I can do the design with one mixer. So I go this here, I will tell him long narrow tank. And yes, look, now we have one. Yes. Why? Because they require the thrust, it's like 50% more. So they put more thrust, okay? And they force more, the consumption is higher, okay? But same time, we have one unit, and here is like the blade angle is 13 instead of 5. Okay, so yes, it's available, so I take this one. Okay, so now this solution is with 2. If we go to compare here, it's 2, and this one with is 1. Okay, but here we are with 2.5, 2.5. This is 1.5, another one. Here the produced thrust is 600, here is 500, it's 500, okay? Why I did this? Because as we said, one mixer is less expensive than 2 mixers. So, or this one, okay? So this is the concept of the long, narrow tank and what each mixer can reach. It depends on the tank geometry. Sometimes our competitor speaks about like open water. Open water is like a thrust. What is the nominal thrust of this mixer? Okay, the nominal thrust of this mixer tell you about this mixer, how much thrust can give, but without any restriction without any boundaries. But this is not the real case. Okay, we cannot compare it. So, and then, so you go what we explained about downloading the documentation. And with this, my part is done. Thank you very much for your time.
Thank you, Kinda. So I will share the 2 tools for doing now. They are temporal tools, I would say, because I hope that in a few months you will have, you don't need to use these tools and you can do it directly in the design tool. So let me share first the mixer. So this is the Excel file with all the local price list. So here you will have access to all the different part numbers because we have hundreds of different configurations. And here you have the local price list of Portugal and all the features of each of these part numbers, of each of these configuration of each model of the mixers. So that's why I created a kind of a pivot table here where you can choose the frequency. This is very important that the frequency, this blank option, is for those mixers that you have the VFD. and that's why you don't have a fixed frequency. So if you want to choose the price list of the variable thrust mixers, the two compact ones and the banana one, you have to choose here the frequency, the blank cell, okay? But if you're talking about conventional ones, usually it depends of the region, but in Europe we have 50 hertz. Here you have, for example, all the different models that we have, okay? So first you have to use the solver selection tool, and the solver selection tool, as Kinda already explained, at the end, you will have perhaps even different options that you want to quote. But if you have one specific banana, for example, this one, the 4410, you can click here, and here you have all the different filters. So if you want the IF3, and that's why I put here for this specific version of the mixers, because this is the model of the mixer, okay? And the three next numbers or digits are the version of the mixer. So for example, if we want to quote a banana with IF3 motor, we have to choose this one, the 800, okay? Then we have two power options, but again, all of this information should come from the selection tool. When you are doing the selection, it will tell you the model of the mixer, the power, the number of blades, the diameter of the mixer, and so on, okay? So in this case, when you do the selection, it will tell you that you need a motor of 2.3, and the number of blades could be 3, and the diameter of the blades will be 2.2, okay? Then you can choose if you want to quote with FLS, with the leak sensor, or without it. If you want to with it, then you will reach to just one part number. So this is a unique part number, let's say, with this configuration that you have choose here, and this is the price list of this one. Okay, so if you want to do the selection, for example, a compact mixer, then that's why the compact ones are more challenged in order to select. Okay, and that's why I put this important. This important note is that when we're talking about the compact mixers, the angle of the blade, you don't have this filter here. So you can, for example, if you choose a 4650, this motor size without the gen ring, what else? This is the diameter, and this is the cable type. Even if you choose all of these, and then with VLSS and the guided option and this version. Even if you choose all of these filters, as you can see here, you will have a lot of different part numbers. Okay. Usually the difference between these part numbers are the angle of the propeller. The price is more or less the same. Okay. So that's why for pricing, this tool is useful. But this tool, you have to be courteous to use it to choose a part number, because perhaps in the selection tool, it's telling you that the 4650, the angle of the blade is 7 degrees, for example, and this part number, however, is 9 degrees, because in this file, you cannot see the angle of the blade. So that's why if you choose this price, be careful with the part number, because if you send a purchase order to Xylem with this part number, perhaps you can do it in a wrong way, because you can ask for a mixer with a different angle of the blade. Okay, and this happens with the compact ones. So again, this tool is useful, let's say, to have a price list. As you can see here, even if you do all of these filters, sometimes you have a lot of part numbers options. But more or less, here you have a price list that you can use and apply your discount. Usually try to use the highest one, just to be conservative, let's say, safety. And that's all I would say. So this is to choose the mixers. As you can see, the number of options is huge. The size of these mixers, we have 12,500 different configuration of mixers. Okay, The 4610 is still there, so you should not use it. But I think they didn't remove yet from the local price list. And that's all from my side in terms of choosing the different products and also to obtain the price. And we also have another tool that we will forward to you. If you have access to quote, it should be easier, let's say, to configure and receive this file. Sorry, this price. And then we created also in order to facilitate and make simpler the quotation phase is for the accessories for installation. That here we created this simple tool that you can put here the model of the mixer, can be 4630, the water level, because the water level will impact on the guide bar length, or can be a banana. So if you put here the model and the water level, then here we have the database. And then you will obtain here the result for the compact and for the banana. So for the compact, for such a specific mixer model and such water depth, you will obtain all of these part numbers, all of these references, and the price list, the Portuguese price list for each of these components, and the total price list for all the accessories that you need for such a model as such water depth. Okay. I put here some graphics, but in the documentation of the mixers that you have in the link that I showed at the beginning of my presentation, you can download such a documentation and you can even see the breakdown and the of all of these accessories. In theory, you have we translated into Portuguese, but please check it, the description, because perhaps some of the words are not properly translated. So hope that these two tools will help you to do the quotation for the mixers and the accessories, installation accessories that you need for them. As I said before, this in theory in 1 or 2 months will be already in the design tool, so you don't need to use these Excel tools. But by now, we don't have any other option. So, any comments? Questions?
David,
Dime, Domingo.
comenta el tema de que todavía la herramienta no está disponible en Solver. No podemos dar permiso todavía, que están solicitando ya la gente.
Okay. For the solver, we cannot give access for the, as far as I understood, for the price list of the mixers. So what Kinda was showing, you will not see it. But this is something that perhaps we will change even in the few weeks. So if there is no more questions, and as I said at the beginning, the best way to learn is learning by doing. So I would suggest that you do the designs and quotations by yourself with these tools. And if you have any difficulties, please reach out to us and we will support you as much as we can.
You will send all the material to the group, no?
Yeah, I will do some translation issues that I found during the presentation, and I will forward to all of you. So thank you very much for attending this meeting, and obrigado.
Okay, thank you.
Thank you all. Bye-bye.
Bye.
Okay, thank you. Bye.